Hello, this is the third video in solving cubics. In example 5, which follows 6D question 5, we've got a problem here, x cubed plus x squared minus 24x plus 36 equals 0. And just to get the ball rolling, I've already listed the factors of 36. Of course, you could do this in your head. I've listed them here so we can refer to them. And basically, we want to go down the left-hand column here. We want to go in numerical order effectively to try and find one of these factors. Do note that it might not exist. None of these it might be that none of these work. But nevertheless, starting with the smallest numbers simply means that your calculations are easier to try and figure out. So here we go. So if let's just assume the left-hand side is p of x. So I've got p of 1 is equal to 1 cubed plus 1 squared minus 24 times by 1 plus 36. That's not equal to 0. So I can leave that. P of minus 1, I'm pretty confident, but I'll do it. Minus 1 cubed plus minus 1 squared minus 24 times minus 1. No, that's just nowhere near. That's nowhere near 0, is it? So we can say that's not equal to 0. P of 2 is equal to 2 cubed plus 2 squared minus 24 multiplied by 2 plus 36. This I'm not so confident on, so let's have a look. 2 cubed is 8, 2 squared is 4, minus 24 times 2 is minus 48, and then we've got 36 added on. This is looking good, I think. 8 and 4 is 12. 12 minus 48 is negative 36. So yep, that's equals 0. So by the factor theorem, x minus 2 is a factor. Okay, so just like in example 4, which is still on your screen, we then use the reverse box method in order to finish this off. It's a cubic, so I'll need 3 columns, like so. We've got x minus 2 as our factor, just like we had the other one as well. That's just a coincidence as far as I'm concerned. And the leading term is x cubed. So I'll put an x cubed here, and away we go. X times x squared is equal to x cubed, minus 2 times x squared is minus 2x squared. Along the diagonal, we are looking for x squared. So I'll need 2x squared to get me back to 0, so I'll need 3x squared to get me to x squared. So there's a 3x squared there. X times 3x will give me 3x squared, and so this is going to be 3x times minus 2 minus 6x. Along the diagonal here, we are looking for minus 24x. Let me see now. So we've got minus 6x. We need to get to minus 24x, so it's going to be minus 18x here. X times negative 18 will give me negative 18x, beg your pardon, and negative 18 times negative 2 is positive 36, and positive 36 is the last term, so that's a winner chicken dinner. And so we've got x minus 2 multiplied by x squared plus 3x minus 18. So we now can do this by inspection. What are the methods we could use for this bit here? We could use completing the square. We could use the quadratic formula. We could use cross method, box method, or by inspection to try and factorize this. So by inspection, I'd have to say nothing. Oh yeah, positive 6 and negative 3 will work for this. So we've got 6 times by negative 3 will give me negative 18. And we've got 6 minus 3 will give me 3x. So it is factorizable. So that's equal to x minus 2, x plus 6, x minus 3. And therefore we can say by the null factor law, x is equal to 2, x is equal to negative 6, and x is equal to 3. And that's our solution. So that's another example. I don't see this as being particularly harder than question 4. Where question 5 might be a bit different is that sometimes this bit here, doesn't matter what you do, is not factorizable. So it may be that when you put it into the quadratic formula, that underneath the square root sign you get a negative number, that kind of thing. So it might be that an x squared is the only second factor that it has. And so you can conclude that the only possible solution would have been just from the linear factor, and there's no possible solution from the quadratic factor. So Just keep that in mind, that you won't always get it down to 3 linear linear factors. If it's a quadratic factor that cannot be factorized any further, then that means there's no solution for that one. Okay, I'll leave this video here and I shall go through another 1 or 2 examples in the next video.